Microelectronics are changing the way we live in a very fundamental way.
How are we as a high-tech manufacturing company in North America going to compete? And I said, we're going to compete based on technology.
It really is a game-changing kind of strategy here.
We found this to become an increasingly valuable place for us to spend our research effort.
Today's research is interdisciplinary and it requires very expensive equipment. And the only way to do it is to form these large teams that include multiple universities in collaboration with industry and government.
The advantage of an organization like this is that it provides a neutral playing ground where these organizations that might not otherwise get together can come together and make progress in a way that none of them can make on their own.
We meet members from the government, from other levels of industry. Essentially, it's a place for the entire supply chain to get together in a cooperative environment.
Well, it's a great environment here because you've got a great university, a great engineering faculty.
We're part of Binghamton University. We care very deeply about the quality of our research.
The analytic capabilities that are put in place are really unique in the world.
We're also very interested in getting very young students excited and energized about research and about technology and about engineering so they can participate in this revolution.
The people here are willing to listen to our input and willing to respond to our needs.
We keep industry at the heart of everything we do in the center. They're part of our board of directors. They're also part of our technical advisory board.
It's a very effective way to find areas to work together, yet be able to still go on and distinguish yourselves with your competitors or collaborators.
Through the proper collaborations of both industry and the universities, we could become the Silicon Valley of the East here.
You find significant overlap between the people that attend the various centers, and you find new places where you can interact.
We interact with some non-traditional partners, if you will.
We can take a 20-inch by 11-inch printed wiring board that's fully assembled, and we can shrink that into a 1.5-inch by 1.5-inch package.
And then there's the whole idea of sensing capability. Sensing for the environment, sensing for your own personal health monitoring. The opportunities are really limitless.
Today, electronics is built on rigid silicon wafers or for displays built on large sheets of glass.
If we had the right technology, had the right equipment, can you imagine what we can do with flexible substrates?
You could conform it to your clothing, you could put it into your vehicles in a curved format, you could roll it down off of the wall, you could roll it out in front of you just like you would a map.
One of the easiest examples to understand is in solar electricity and solar panels. If you move from your house, you can roll your solar panels up and take them with you.
Flexible electronics has wide implications for the soldier. You can think of having a small display that's velcroed to the soldier's arm, wirelessly transmits to a radio someplace in his backpack that tells him a simple map, for instance. It tells him where his buddies are, where he needs to go, and basically uses no power.
This center is about making electronics faster, better, lower cost, and more durable.
There's tremendous opportunities through material science and the integrated systems and shrinkable electronic packaging to take weight out of systems.
To make microelectronics even lighter, flexible, wearable.
To make cars much more fuel efficient, airplanes much more fuel efficient.
It's going to change the way we live completely.